I'd like to welcome everyone to the last of our OWASP Cambridge and BCS Cybercrime Forensics webinar talks for 2025. We will have a full program for both individual organisations and joint events next year, and we will be having BCS AGM on the 22nd of January with another speaker. I'll advertise that more in advance. I'd like to say the ground rules for Zoom sessions is everyone is obviously deliberately muted by the presenters. Questions we will take in the chat, please, and we will have a Q&A session at the end. It's my great pleasure to introduce both Siegfried and Simon, who are part of the OWASP Operational Technology Top 10 Vulnerabilities project. And they're going to be talking today to show us really that why OT is the poor cousin compared to IT, because there's software in both. Over to you guys, and thank you very much.
All right, thank you for your introduction, Adrian. Maybe before we start with the actual presentation, just some introducing words from ourselves. I'm Siegfried Hollerer. I'm a security architect and analyst, is at least the official job title. I'm one of the guys from the Federal Ministry of the Interior of Austria, which are enforcing the NIS law. So if you heard about this law, this is about to protecting mainly the critical infrastructure of a country, while more or less securing it with some basic security measures. And this goes also to some extent to a strong relation to the OWASP OT Top 10, which we are introducing in a few minutes. And besides that, I'm also lecturing at the University of Applied Sciences in St. Pölten, so it's also a small city in Austria. And I recently finished my PhD thesis, where this research project, which was based on this PhD thesis, involved the integrated modeling of safety and security requirements for industrial applications. So this is also something which has strong relations to the topic that we are discussing right now, but extending it with safety requirements. So if someone is interested in this topic in particular, the Q&A session is also open for this as well. And with that, I will hand over to Simon.
Yeah, thank you, Siegfried. My name is Simon Romer. I'm not so distinguished. I'm more on a hands-on. I used to work in a security operational center. I did forensics. I did basic firewall administration. I did system administration. But everything and every time with a OT focus. So I learned electronical engineering, mechanical engineering in school, and started cybersecurity, and then went into basically cybersecurity. Pet peeve of mine is that cyber is no word, so that's why we call it OT, operational technologies, but more on that later. And yeah, so currently I'm with Omicron, and I'm a OT security consultant, which basically means is I do everything what the customer asks me to do. And I have no short description of my tasks, but I'm working with also the NIS and IEC 62443. And just as an additional side note, there is something similar to the NIS in the UK, the GCHQ, and Europe, the ENISA, the European Cybersecurity Agency, they work very closely with this. So when we talk about NIS, it's also relevant for the UK.
All right, then let's go. For that, I will just share my screen, just a second. And here we go. I guess here it's not annoying that much. So welcome to the introduction to the OWASP OT Top 10. You are most probably aware of OWASP itself. So we'll just use some very small introduction words for that. It's the Open Worldwide Application Security Project, as you most probably know. It's an open community which aims to increase software security. All right, so far so good. The background, the origins of OWASP is actually on a very specific narrowed down scope, which is web application security. And here, that's the reason why we also see already the potential outcome from all these OWASP projects. So typically the result from those OWASP projects is to provide free tools and documentation. And when we think about the background for the web application security world, for example, the famous OWASP ZAP project is here, which is a web application HTTP proxy where you can analyze and monitor web application traffic, basically. And the OWASP Juice Shop, which is a intended to be vulnerable web application where you can get your first web application penetration testing skills, because this is a lab environment where you can just it is intended to be exploited by someone who would like to learn on a practical basis how to do that. And I guess the most famous thing which made OWASP famous was the traditional top 10, which is a list of vulnerability categories of the most critical and common vulnerabilities that are out there in the web application security world. And as you see here from the origins, it was very narrowed down to web application security. Then the scope step by step was extended to software security and application security. And right now it is further extending, also leaving the boundaries of the classical IT, also looking at other technologies like IoT and OT. And this is the reason why we thought about a similar top 10 list, but for OT. But first things first, what is OT actually? It is the abbreviation for operational technology, and this can be applied in quite many different things. So for example, it can be used for the railway transportation system, or for energy generation and distribution, or for for smart manufacturing, for process automation. And if you would like to do process automation, which is basically automating manual steps to generate some part of some kind of product. So this can also be applied in many different ways. For example, to produce medicine in a pharmaceutical sense, or to produce oil on using refineries, and so on. So there are many different application scenarios actually where OT comes into play. And also all those critical infrastructures that we're using, also providing the water infrastructure, for example. We already talked shortly about energy and so on. So this is also part of OT, also the healthcare and medical devices, some scanning devices and so on. It's also part of the OT technology. Basically, the core distinction between IT and OT would be, on a very conceptual point of view, that OT systems somehow interact with the physical world. And in the traditional IT, you have just a cyberspace, so to speak, but with no direct interaction with the physical world. And this interaction with the physical world leads then that in OT systems, you have additional risks to consider. So for example, based on this interaction, if something goes wrong, this has then an effect on the real world. And if right now person is interacting with this OT system, this person may get harmed with some malfunctioning or faulty behavior from the OT system. So there might be health risks here to consider from a safety point of view, or the environment might be damaged where the OT system is located at. So these are the new risks, but also you have some different system characteristics with respect to IT, coming from an IT point of view. So you have typically also very high availability requirements. The classical IT, it's not that important, so to speak. In OT it is, because typically you have there 24/7 all the time, more or less, production environment in there. If you have some delay or outages for some hours, it results very fast in a high financial loss because you are not able to produce your products and so on. So therefore, you have a very high emphasis on availability. You are using unconventional operating system, at least with respect to IT. So you do not use typically some commercial off-the-shelf products in like it is done in IT, where you just buy a server, you install your favorite operating system, some software, configure it, and that's done. In the OT, you have here, of course, also some firmware and some kind of a software, but the difference here is that your OT system that you have built is an individual use case, and you also have programmed an individual process logic for that. So it is very specific, very tailored that we have here in this OT system, which makes it pretty complex in the end, because you have always to think through it with the glasses of your OT system, so to speak. And with respect to IT, you have much longer operating and lifetime cycles, but we will discuss this in a little bit more detail in the following slides. First things first, why it is interesting to actually think about OT security. Why not just think about IT security and adapt it a little bit? So here, the situation why dedicated OT systems are interesting from a cybersecurity part of view is, if we think a little bit about into the history, we see that approximately with 2010, the very famous Stuxnet incident occurred. Here in this situation, a nuclear power plant was attacked. And we see here also throughout the timeline that right now, and also in the next slide, that the difference between those years where such an OT security incident happens is getting smaller and smaller. And now we have the situation that in each year, at least one very big critical famous OT security incident happens, which also have an effect on safety. And therefore, since there's obviously a rising trend, because many attacks are known out there, and if you're looking to the future based on this information from the history, we will think that there will be again some rise in the direction of cybersecurity attacks targeting OT systems. Let's start with some basics. OT versus IT security. So we have basically here in such a world where we have an OT server system up and running, the application of two different technologies, which is IT and OT. I guess I'm pretty sure that you are aware what IT is actually, so we'll skip that. OT, we already discussed it a little bit. And here, coming from those different technologies, we have two different protection goals, basically, to consider. So coming from the IT world, we have the security to fulfill, which is basically aiming to guarantee to have confidentiality, integrity, and availability secured, so the CAA triad. And safety, coming from the OT world, here the goal is to protect everything around the OT system from the OT system if it's malfunctioning or if it has a faulty behavior. And therefore, the core goal is here to protect against hazards, which could be hazardous to humans and the environment. So this could basically be depending, of course, of the process that you have implemented in your OT system, but maybe during the process to make your product, you have, for example, to deal with explosive gases or poisonous gases. And then if something happens that the poisonous gas, for example, comes in the near to some people, then you have then, of course, a safety hazard which you have to consider and have to counter. From a security point of view, we have a different prioritization of the CAA triad in the OT. So in the classical IT, you have the situation, that's the reason why it is called the CAA triad, because on a very generic, abstract level, typically confidentiality is the most important thing, coming with integrity, and after a long pause, there comes then availability, which is, with respect to the other two, rather negligible. in the OT world, it's exactly the opposite, where availability is the most important thing to protect, followed by integrity, and after a long pause, there comes then when confidentiality. And this has a huge difference. So for example, when we are considering some kind of IT application, for example, a web shop, if this web shop has some kind of a outage or a delay for, let's say, just 2 minutes, then it may be a little bit, disappointing if you cannot access directly your favorite web shop and you just grab some coffee, take a sip of it, and then you continue accessing the web shop and can finally buy your product. Then in the end, it was maybe a little bit annoying, but it has not even some kind of a financial loss, this whole situation. On the other side, when we look into the OT world, here it can be pretty bad when for 2 minutes railway barrier is not reacting in time. So here we have then situations where hazards arise, namely that maybe a collision is possible and the railway barrier does not close in time. The train is coming right now and the car is in the same time passing the railway station, leading to a collision. And if you're lucky, only the car is damaged. If you're not so lucky, then people in the car also get harmed, injured, or even worse. And therefore, 2 minutes, so more or less the very same scenario in IT and OT, can have quite very different effects in the end. And therefore, in the OT world, the worst case scenario is basically the loss of safety, which is dependent of availability. Because if you cannot guarantee that you are able to react in time, you are not able to trigger your safety function, which should counter a dedicated hazard. And then loss and manipulation of control is, of course, also not desirable, which is then an impact of integrity in the end. And the loss and manipulation of view is, of course, also not desirable, which is just confidentiality. But if you look at the other tools, definitely loss of safety is by far the most worst case scenario out of these. And this focus on availability leads us to the situation that we have to rethink OT security with respect to IT security, because typical security measures like implementing a patch management where you do regular patching on a frequent manner cannot be implemented directly like in the IT in the OT, because if you would like to do your patching, in this process of patching, you have to download the patch, install the patch, maybe do some configuration, maybe you have to reboot your OT device. And these are all steps which lead to the scenario that the OT device may not guarantee the availability which might have to be guaranteed. And therefore, this can have, again, a huge effect in the OT system. This, of course, does not mean that you should not patch, because of course if you do not this, then you are open for all vulnerabilities which are out there. It's just a matter of time until your device is also vulnerable then, and there you come into the situation where you have to patch maybe on not so frequent manner, maybe during maintenance windows, which happens typically depending on how complex the OT system is, maybe twice or 4 times a year, which means that even if you patch on a relatively fast pace, that you still have the situation that you're open to vulnerabilities which are already 3 or 4 months old. But this is as good as you can go on a patching perspective, leading you to the situation that you may have to include many other layers of defense as well, besides patch management, or else you are just vulnerable. Then what's also interesting here is that availability is also already in product development to be considered, leading to the situation that until now, again, plain text network protocols are still in use. Why? Because if you implement encryption this, of course, needs some computing resources to be implemented. And if you have your devices in place who has to react fast, but on the other hand, have to encrypt the message, then send it over the network before they can actually interpret it. They have to decrypt it, and this encryption decryption, of course, takes some time to calculate. And this is then again some kind of a small time window which is needed for performing the encryption, but this could be this very small amount of time which is critical to actually react in time from a safety perspective. And therefore, you have still conceptual problems to directly implement encryption in the OT domain. Another interesting point is when and how to test, because if you have some experience in penetration testing, you may have encountered the situation that maybe you have unintentionally on a stress test or just fuzzing and so triggered your target device in a denial of service situation because it's just overwhelmed by all those requests. And this can happen in the OT world relatively easily because besides of all those vulnerabilities that are conceptually there because patch management is an issue, you have another issue, namely that you are using legacy devices there, which per design do not support some security functionalities. And besides that, they're relatively slow, leading to the situation that actually experienced this in my past as a security consultant in the industry, where some guy actually only did an active port scan, which was already enough for the corresponding OT device to get in such a denial of service scenario where it is just overwhelmed by requests and does not react anymore. And this is, as I just presented before, more or less the worst case scenario, which was then triggered unintentionally during the testing. And therefore, similar to patch management, the when to test also goes in the direction of during maintenance window when there is an intended outage where you do not interfere with your production environment. And the how to test will also be more on maybe on a manual approach or on a very delayed, more stealthy approach if you do some automatic tests and so on. So you have also to think and behave differently here from an aggressive point of view, or else you will unintentionally damage your OT system. Another topic here is potential regulations. So as we already had the short introduction for NIST, there are other regulations as well, like the Cyber Resilience Act or the AI Act, which has also some security stuff written in there. And this is also in some OT systems already used. And then you have the situation that you may have to obey multiple regulations, and each of these regulations maybe have the same security requirements, but on a different detailed grade. And then you have to think, okay, the security measures I have in place, are they sufficient for all regulations that I have to obey, or just a set of them and so on? So this can also be some kind of a topic which could give you headache from a point of view from the asset owner. A core difference is also the life cycle. In the traditional IT, you have a relatively short life cycle. So all those 2 until 4 years, your laptops and smartphones and so on are then exchanged with new ones, leading to the situation you can directly use the state-of-the-art security mechanisms and functions in there. This is not possible in the OT world, where you have the same component in use for decades. And when you think about which technology was there 30 years ago at the asset layer and at the protocol layer, you may already get the impression that it is pretty hard. So even if these things are patched, it is still hard that, since they may not supporting some basic security functions per design and cannot be somewhat backported, you still have on this direction many open vulnerabilities which are per design hard to counter basically. Another distinguishment would be the supply chain. So you have three big parties basically in the OT world, which are the vendors and the manufacturers. So basically the guys who are designing and building those OT devices. Then you have the integrators who are building an OT system, so designing and building an OT system based on those OT components or devices coming from the vendors. So they're also doing the networking between those devices. So the system is here. Also programming the process logic that the OT system has to implement. And the asset owner are the ones who are using this build OT system. And therefore, you have the situation that the asset owner typically has only more or less user access to the OT system, and the integrators still have administrative power on the system. And they also use this for maintenance and also extending the system and so on. And therefore, since on the same OT system, two big different parties are dealing with the asset owners and the integrators, which have to be working together on a close extent. This is typically dealt on a organizational contractual level with SLAs, service level agreements, where the parties define there, hopefully, how to deal with all those security stuff. For example, with patch management, maintenance, and all those stuff. And here, typically, you have here some clauses that an integrator typically denies an asset owner to do some administrative stuff and changes on the system, because this would then also lead to the situation if an asset owner would, as I said in the beginning, just do patch management like it is done in the IT. This could then lead to the situation that the OT system gets unstable, cannot provide the availability level and requirements as it requires or provides right now, leading to the situation that it's maybe not usable anymore. And therefore the integrator says, okay, if we're really doing such changes in there, then I will not guarantee anymore that it behaves like intended, leading to the situation that then the asset owner most probably will not take this risk, because if something really happens, which is quite likely the case, then this will then lead to a huge financial loss. And therefore, you have to very clearly and precisely define here in the SLAs who is actually doing which task that is needed to increase the security. And there's also, of course, a very high dependence on the few vendors that are out there, that those vendors are actually supporting security functionalities, which can be then afterwards implemented by the integrators and used by the asset owners. So to sum up, we have a very high focus on safety and availability in the OT world, and not really security. Here with security, I mean confidentiality and integrity, but mostly confidentiality. The devices are hard to update and patch. There are very long life cycles, leading to the situation that you have legacy devices to deal with. You have only a few vendors and integrators, so you have this supply chain problem basically. And this leads to the situation that, of course, the OT devices also have to be protected, otherwise they're vulnerable and can be attacked. But since you have very limited possibility on the device level to actually improve security of the OT system, you may have to focus more on the network layer. So for example, dealing or focusing on network segmentation or access control, or also physical access control and so on. And since now we have discussed a little bit all those differences from the IT and OT world and security and safety things coming from a defender's blue team perspective of this whole OT topic, we are now switching to the red team point of view, how an attacker might actually attack an OT system.
But before we going really into the red team part, I want to give a little bit of context, because the cyber kill chain, quote unquote, might not be a thing, or might not be familiar with everybody. So that's why we're going to have a little bit of an excursus. Most of you might know the MITRE matrix or the MITRE enterprise matrix, but I guess the minority would know the Purdue model. So let's start with the Purdue model. Since the Purdue model was developed at Purdue University to try to standardize the view of a network in the OT space, so in industrial environments. Sigi said in the beginning that OT also encompasses medical devices, for example, and also it encompasses um, building automation and all the other good stuff that is not traditional manufacturing or power plants, facilities or something. So you can also do an insulin pump in a Purdue model, for example, but you need to go down to microcontroller level. Most of the times we don't talk about insulin pumps, but we talk about manufacturing facilities or pharma or biochemical processes, or in my case, in the energy sector, we talk about power plants and substations. And this is a common view how to draw such a network. So we start at the top. IT is Purdue level 4 and 5. So we call it the enterprise and business network. This is where the quote unquote normal office workers are. This is where most of the attacks coming from through phishing or exposed networks or exposed services. Then we're going to the DMC. This is just a normal DMC like in IT space, but we call it the IT OT DMC since it's the interface between the IT and OT. And here are the jump servers, patch servers, historians. Sometimes you have your own Active Directory or some kind of identity management in here. Here are all the services that need to be available from basically both sides. Level 3 and down is where it gets tricky because now we're entering OT. So OT also has a few different steps that you need to be able to operate. So the operation in operation technology is not really straightforward. That's why we need a few extra layers. So in the operation systems, we have workstations, historians, I/O servers. In the supervisory control, SCADA is supervisory control and data acquisition. So it's basically remote controlling the manufacturing processes and monitoring all the devices and such. HMI is a human machine interface where the engineers go and manually control the machines. In level 1, the process control, so the PLCs, the programmable logic controllers, basically what makes automation possible. RTU is remote terminal units, DSC controller, and SS. SS is the more important one. It's the safety instrument systems. These are high available systems that are only there for your own safety. And they also can impair or disrupt the processes when safety for the user or for the human is in danger. So in the level 0, we call it level 0 because I always like to explain it. There is no IP addresses anymore. That's why we call it level 0. But here is the interface with the physical world. We have sensors, we have actors, we have pumps, we have measurement systems, and so on and so forth. So basically, this is the Purdue model. To be able to understand the OT kill chain, we need to understand how an OT network is built and how it looks like. What you see on the right is part of the cybersecurity kill chain. So I hope this works out. So the kill chain was introduced by Lockheed Martin, coming from traditional warfare, where they tried to have like their quote unquote experience from the battlefield and try to do something similar in the cyberspace. Since, as Sigi mentioned before, one of the first OT attacks was on a nuclear power plant. This can also be seen as an act of war. So that's why they wanted to have something similar for the IT space. We categorize it in 3 common steps. So we're going into the network, we're going through the network, and we're going out. I don't want to go into every little step here. You can look it up at unifiedkillchain.com. It's basically standard in the industry, so knowing this is always quite good. The thing with the OT space now is, if you know Mitre, this is basically the same as the kill chain, but in a different way. So we have reconnaissance, we have resource development, you have initial access, you go in, you have lateral movement somewhere, you have execution persistence, you have privilege escalation, you go through, and then you have defense evasion credential access and lateral movement. This is still through, and in the end, you do something which is exfiltrating data and or impact something. And this is the exfiltration and the impact, and then you go out. So this is the IT space, right? But how does this look in the OT space? Because OT is always a little bit different. We still have the same matrix, but we have way fewer steps. This is not because there is not so many techniques, but the networks are very small, and these things are dependent on devices, services that are not available in OT. So in OT, you have also initial access, but then you need to execute and have persistence. You also need privilege escalation. Then you need evasion again, discovery, lateral movement. So the numbering is different. So the order is different. But you also have impair and impact at the end, but this time it's impair process control. So we're talking about reporting messages. We're talking about block reporting, serial messages. Denial of service was something that we already mentioned. Manipulate input-output images. We're talking about HMIs and so on. So there's different protocols, there's different things that we want to do. And now to be able to combine the enterprise part and the ICS, the industrial control system part, in one of these kill chains, we need to go back to our Purdue model, and we see that we have in, through again, and then we go out, because we go into the enterprise network, we go through the enterprise network, we go into the OT network, we go through the OT network, and then we do the stuff we want to do, basically impair the control processes, impair the operational technology in the OT space at the very end. And with that said, we can go back to the OT kill chain. This was just a quick refresher on how OT networks look like. So should have pressed Shift F5, then I would have been at the correct slide. But we are here again at the OT kill chain. You will notice that it does look different, but it's basically the same it's basically the same steps in a different way. So you always have your reconnaissance, you always have your planning in the beginning, because you need to know what you're going to talk about. This is so important that when the Russians attacked the Ukrainian energy grid, they even built a smaller version of their substations. So from experience and from intelligence, we know that before the attack, they had the same Siemens PLCs, they had the same Siemens HMIs, and they tried to find zero-day exploits on those devices, so that in the case afterwards, they could use those zero-day exploits that they develop. So you always need to have reconnaissance. This is open source, this is scanning, this is everything from outside. Then preparation. Preparation is extremely important, as I said, because it's highly individualized on the target system. The cyber intrusion is attempt and success. Hopefully not so many attempts and no successes, because you have some kind of network intrusion detection system that is alerting on malicious behavior. most of the times the attacker needs to have some kind of communication channel into the network. This can be some kind of remote code execution possibility. In the most simple way, it's some kind of team viewer session or RDP session. It can also be a dropped Raspberry Pi with a UMTS card in it, and then it is connected to the network. So this is basically still IT stuff, but in OT space. So you can drop the Raspberry Pi into some kind of substation or some kind of facility, plug it into a Ethernet port, and then you have the same attack that you can do in IT, but in an OT environment. And if you're in the deep, then you can do basically all the tasks you need to do up until execution. So execution is doing the goal, or basically we call it action on objective. So as I said, it's similar to classic IT. The stage one is always gathering information, getting initial access, planning your attack so that when you're inside the network, everything can go swiftly and can go smooth, so that you don't make so much quote unquote noise. The delivery phase is quite important if your exploit is not up to the task or if it has some bugs. So exploit developers don't need to think about good programming guidelines. It just needs to work. So there doesn't need to be some kind of error messages or so on. So it can happen that if you develop an exploit, it can fail. And this is why the reconnaissance, the planning, the preparation is really, really important, so that you have all the information you need to develop a functioning exploit from the attacker's point of view. You also need to install the exploit. So if you only have the exploit and you're not using it, it's basically useless, of course. But the exploit can only be installed if you have access, if the planning, if the preparation, the reconnaissance again was successful. C2 connections, I'm going to skip this a little because it's the same in IT. As I said, it's basically just some kind of communication into the network, and then the sustainment, entrenchment, development, and execution, it's basically the same again. A few years ago, it was really trendy to have some kind of ransomware in your OT environment, since the computers were kind of old. So the 30 years that Sigi mentioned before, it was not some kind of random number. So 30 years in our line of work is quite new, actually. So we also have substations that is like 40 years, and sometimes if you have bad luck, there's 50 years also. And there is Windows XP still going on, and you can ransomware Windows XP really easily nowadays. So this is basically an IT attack in the OT space. And since the devices are all really outdated, it can be really easy for the attacker. So, but the most, in my opinion, more interesting part is the stage 2, because now we're going really into the OT specific stuff. So we're going for the development and tuning. Every OT system is different. Every OT system is highly specialized, as Sigi also said before. So even if you have the same hardware, the configuration might be different. There might be different settings, so to say. Or for example, one IDE or one HMI might have a password, might have 2FA already. For other IDs, it's not activated, and the password is 0000. And you need to adapt to this. From a attacker point of view, I really like the 0000 passwords. Sometimes it's just default passwords from the vendor. They set the password differently from the 0000 or 1234, but it's always the same default password, and you can look it up in a database online. So if the customer, quote unquote, if the company that is attacked has ISO 27001 or 62443 certification, they most likely change the password from the default one. The example I brought with the Russians having a totally small, totally functioning small substations, they did the validation, for example, in-house. So they didn't need to do the validation on the target system. They just did it in-house. Yeah, so the impact is different for most systems. So depending on the system you want to attack or your goal, the impact should be different. So if I'm a nation state actor and I'm in a state of war, I want the enemy to not have energy, for example. If I need to do cyber espionage, I want data exfiltration. If I'm a criminal and I want to ransom somebody, I need to have some kind of control over their system. So the impact is always different depending on what your goals are. But it can be loss of view, which means you don't have visibility, so you're not able to monitor the systems anymore. So you can't control the systems. In a case of emergency, you can shut down. Manipulation of view is what happened with Stuxnet. With Stuxnet, the malware made the centrifuge spin more slowly and faster and more slowly all the time, but the monitoring system thought it's continuous, and this made the centrifuge fatigue faster, and then it broke. And again, the monitoring system thought it was continuous, so they didn't know what the problem was. This is an example of a highly specialized impact. So, but now that you're all OT experts, what is the OT top 10? So basically what we did is we took the principles of the normal OWASP top 10. We gave it names, description. We thought about why we put the items there. We put down known attack examples, also with real life examples, mitigations and countermeasures, also referencing the MITRE matrix. And if you're a system owner, we also provided next actionable steps. So what do you have to do to not be vulnerable to these top 10 items? And also, since we are talking about a lot of standards, we put references down. If you want to look it up on, for example, the NIST or critical infrastructure, the CRITIS or Cyber Resilience Act, or whatever your local government is telling you to do as a critical infrastructure owner. So, drum roll, these are our OT top 10. With that said, thank you for your attention and see you next time. Jokes aside, we are going to talk about a few of those. And please, if there is one or two that are interesting to you, you can ask specific questions afterwards, or I don't know if I can have a look at the chat. If there is questions, we can also do it right now if it's really important. No questions so far. Then we just go ahead and go for one of my favorite top 10 items, the unknown assets and undocumented services. The reason why it's my favorite is because it doesn't matter where you go, it doesn't matter what kind of system you have, this is always an issue. So we all know documentation is something that needs to be done, but we also all know that documentation is something that is most likely not done sufficiently. What we mean with unknown assets and undocumented services is there is not recorded devices or services in the OT systems. And if the OT system is quite old, then the not recorded devices is even older. And this means that an attacker that does some kind of scanning or finds the device has an easy life with exploiting and using it as a pivot point, for example. Also, the vulnerabilities are easy to exploit and hard to patch with older devices. And even if it's a newer device and it's out of scope, it doesn't get patched. So unknown assets and undocumented services are always a big no-no for security. Case in point is RDP service on an old device where you can exploit Eternal Blue from the internet. So this would be the worst case scenario. Loss of availability, as we said, availability in OT is the highest goal besides safety. And we need the availability in services, in processes, and in real physical devices. So basically, the reason why OT exists is based on the availability. What we also did really, really accurately, because this is something that helps the reader the most, in my opinion, is the mapping table. And Sigi was a really big part in this. We linked each of the OWASP OT top 10 items to standards and also gave the chapter in the standard. For example, the IC 62443 is a really big standard, and we linked it to the chapter and the part so that you don't have to buy the whole standard if it's applicable, but you can just look it up, what you need to know, basically. Also, the EU NIS2 implementation regulation. In the UK, as far as I know, GCHQ is responsible for this, and there is also something called the information, the commissioner. So please, Adrian, correct me if I'm wrong.
Information Commissioner's Office, I think it's.
Yeah,
ICO,
thanks.
yeah.
It's the Information Commissioner's Office. I'm not so good with the UK regulation, but they give notice on the NIS2 and how, even though Brexit happened, they still implement the NIS2 in the UK and how they do it, basically. And the ISO 27001 is just important, always, everywhere, all at once. It's basically how to do an ISMS. And with that said, I think.
Yep, I will take over again and share my screen. So
you can also say something to the mapping table, because you were an integral part on doing it.
Definitely.
Basically.
This is some kind of a small baby of mine, and here would like to elaborate a little more, because especially we see here the ISC 62443 standard service, which Simon has already introduced a bit, and the reason, besides the more or less limited need to part those different chapters that Simon mentioned, is also here, if we understand the logic of the ISC 62443 standard series, which is as follows. As you may remember from the introduction from my side, from those different parties in the supply chain that are needed to consider, namely the asset owner, integrator, and the vendor, you have to view on the very same security topic with slightly different viewpoints and angles. And this is the reason why we have such different chapters here in the standard series. So each of these chapters addresses a viewpoint from a different party from this supply chain. This makes it really nicely, because here those different chapters are also stating in there how their viewpoint relates then with the corresponding other viewpoint of the other party in the standard series. So this is quite comprehensive, including all those relations throughout the whole supply chain. Of course, this leads then to the situation, since it's so comprehensive, that it's also relatively complex if you want to think through this again. So it may be a little bit overwhelming if you're new in the OT security world and you start already with this whole big standard family. On the other side, the NIST special publication 882 version 3, which is the most recent one of this document, may be interesting for you if you are relatively new in the OT security world and you are an asset owner. So this document is directly focused only for an asset owner, and for that it describes on a very conceptual basic point of view what are the key security measures and relations that you have to consider, and therefore it's a good starting point in the OT security world from a viewpoint of asset owner, but it's of course not that comprehensive than the former one. The NIST cybersecurity framework, which comes more or less from a pure IT world, is very abstract and generic and very conceptual. And this is the reason why we can directly also apply this framework to the OT without rethinking. We already talked, or Simon already talked about the MITRE ATT&CK framework, so I will let this be. We also talked about the NIS2 implementing regulation, where here are those risk management measures. So that's the terminology which they're using to refer to dedicated requirements. So these are then also again mapped to our OT top 10 categories. And as Simon also said, the ISO is typically very important in the IT security world, but it has a very specific focus on IT security. So it does not have this rethinking that is needed for the application to OT. But still, if you use it for organizational stuff, it can still be useful also in the OT. And that's the reason why we selected the section 6 from this IT specific standard.
There's just one thing that I still want to add. I said I'm not quite familiar with the UK standards. We are dealing with the Austrian standards. The Austrian standards are based on the European standards. There's different standards in the US. For example, the NIST is US American based. And there's also some different standard in Asia, and they are based also sometimes on American or European standards. And you see, this is quite a lot for one person to know. So if you're dealing in some kind of different country, please inform yourself beforehand what kind of standards apply to your region. So, for example, I'm dealing with the 62443 a lot. I'm dealing with the NIST and NIS2 a lot in Europe. But I also have a colleague that deals with the local standards in Ireland and England, for example. And I have some colleagues that are dealing a lot with the standards in some of Asian countries. So this is an important part. We listed a lot of different standards, but if you are looking deeper into the world of the OT space and regulations, please look up what kind of regulations apply to your specific case.
Yeah, that's definitely a very useful hint to have in your mind when dealing with the stuff. Let's continue with the emergence and contribution. So what is actually the methodology behind the OWASP OT top 10? So all the top 10 items that we on a very high level have introduced and presented to you are based on public reports and analysis. So for example, we analyzed the ENISA threat landscape 2024 and the CI sector landscapes, also threat reports from different vendors and manufacturers, best practices and experiences from the industry. And since we have many contributors coming from different parts in the industry, we of course also included their experience and expertise for that. So for example, we included the knowledge gained and results derived from the pen test sensors from Lima Security, also some analyze report from Omicron Energy, and so on. So we had quite some information, some data already here, which we used for defining those OT top 10 items for this initial release. The contributors who contributed to this project up until now had the following experience. So some of them had some OT penetration testing and security testing background. So the techies, so to speak, dealing with the assets and those devices itself. Also OT security architects who are dealing more with the OT system as a comprehensive thing, so focusing more on the system itself and it's implemented and up and running. OT security analysts, also some guys from an organizational or management point of view who are also bringing their insight to the table. Then people with an OT vulnerability research background and people with an incident and response background, which is also a little bit differently done in the OT world. Some of us have an academic research background, so we do not have only the knowledge coming from the industrial practice, how it is done right now, but also some future involvements, state-of-the-art knowledge, how most probably the current trends are going to involve, and such line of thoughts are also included in the OWASP OT Top 10. And of course, like every other project, this project as well is a living project, meaning that all those vulnerability categories we have identified right now in this prioritization may not be final. This may change throughout the time. Here is a list of the most active contributors up until now. And the release of this OWASP OT Top 10 was in October 2025, so it is a relatively new project. It was the initial release, which means the release cycles are not yet fixed. So we are discussing right now how often we will do this, maybe every 2 years, but it is still open and a subject for discussion. And we see here a link to our project repository of the OWASP OT Top 10, which is managed on GitHub, and it is, of course, open for all feedback from your side. So if you would like to give some feedback, contribute some content, or even if it's just correcting a typo, you are very welcome to provide your input, and we will appreciate it if you share your thoughts. And this concludes basically the presentation of the OWASP OT Top 10. And here are some contact information from our side. Thank you for your attention.
Thank you both, Siegfried and Simon. Very much appreciated. I'd like to say thanks for giving your time up this evening. And questions, please, anyone. And if anyone has any questions, if you can put them in the chat, please.
In the meantime, I tried to answer a few questions
Yeah,
in the chat already.
I saw that there was one of the key challenges listed for unknown assets and undocumented services. What skills gap do you see in the industry that makes achieving full assets visibility so difficult? Do you have any tips?
Yeah. I can just summarize real quick. The problem with the assets or the missing assets or the missing documentation is that most of the facilities are not new and have grown historically over time. And as I said, documentation was mostly there in the beginning and didn't get upgraded or updated according to real life scenarios. So it's not a skill gap, so to say, but it's more of a process gap. So if you want to go into these kinds of things, the ISO 27001 or all the standards, getting familiar with the standards is one way. And there is a lot of companies out there that try to offer solutions for a process problem. NIDS, so network intrusion detection systems, can be used for these kind of things. Maybe Siegfried also has a few words to say about this.
Yeah, sure. What I have in my experience seen here is that depending of your OT system, they can be quite big and complex, that you have very, very many devices in there. So if you're going down to your device management or asset management, also including all those sensors, actuators, and PLC, this could result that you have already 200 or 300 different items that you have to consider, which is true for this state. But if you have some kind of a small change, you maybe do not think about to also change the corresponding network topology picture based on that, where we have again the situation of an organizational issue that Simon already pointed out. But I guess also the rich variety and just the sheer amount of devices which are out there is already some kind of a part of the problem, that it is typically a little bit overlooked, that you already monitor or identify these devices. And on the level 0 down there, where you do not have traditional network communication, you more or less are forced to manually actually detect this. So if you have the means on level 1 or above, you at least have somewhat of a network connection, and then you have at least a possibility based on the network connection with all those heartbeats and so on, that you can identify automatically, okay, this asset is here and communicated from here to there. But if you are down one more level, you just have to manually identify it. And this makes it, of course, pretty prone to errors.
Thanks. I think Nick had made a comment about lack of budget or budget cuts in the top 10 vulnerabilities, and Simon had replied to that. Yes, it's an issue. Yeah.
So there's only two types of companies: those who have been hacked already and those who have so will be hacked in the future. And if it's the case, then the budget is never the issue.
Yeah.
So this is my experience, and I think Siegfried will happily agree.
Yeah, I basically second on that. So typically, of course, when you are not affected by attack until now, for you, it is just a risk which may come somewhere in the future into play or not. But if you already experienced that and also have suffered from the consequences, which could be very huge financial consequences, then typically the budget is way bigger than it was before. And besides of the budget discussion, we have all those regulation stuff that it should also be easier to get the budget, because it's not just a discussion anymore if it's risk dependent or not. To some extent it is still, but nevertheless you have some basic security requirements you still have to fulfill, even if you would say I'm not agree that have to implement this security measure to some extent.
And also the comment was the seal will XX going to prison. Sigi, as far as I remember, there is something in the NIS 2 that the top level management is also personally held accountable for mismanaging.
This is true, but NIS 2 is an EU directive, leading to the situation that all those EU member states have to implement this EU directive according to their national law. And this is especially with this requirement not that easily for each country. So not all of the EU member states have already NIS 2 implemented, and there are still discussions how they should implement this. And also this is one of the requirements which leads to heavy discussions.
So Nick, if you're interested in these kind of topics, just a quick side note, I am as well, and I am for harsher fines and so on. So keep the eyes open on what the GCHQ is doing.
Okay. I think Ashok has asked, what different standards across different continents? How difficult is it for multinational companies to manage technology systems in different countries and continents?
Having different projects at the moment on different continents, it's very difficult if you're not standardized within your company. So as I said, the 27001 is basically standard all over the globe. The 62443 is a guideline, a very good guideline for most of the national laws. So the best practices are more or less the same all over the world, depending on what kind of industry you're in. If you're a company that does multinational projects, normally you focus on one type of industry, and within this industry, you know the best practices. And if you follow the best practices, you don't have to worry too much about the regulations.
Okay, and someone else says, thanks for the presentation. I wonder if AI is already involved in cybercrime processes like this, like it is for MLOps.
Ziggy, you wonder, or should I?
Yeah, I'm just searching for this question in the chat.
It's on the last one, the way down.
Yeah, thank you. But please go ahead.
So AI is a kind of hot topic at the moment. A friend of mine wanted to buy and build a new computer, but DRAM prices are insane. So AI, I don't really like it for this reason, but for a professional reason, it's really important. It's coming. There is also AI now in Kali Linux, so there is automated penetration testing going on with low effort, which means that script kiddies and amateurs have more sophisticated means of attacking a facility and are more capable now than ever. On the defensive side, yeah, there is a lot of going on the CM and SOA, but in the kill chain, the steps are the same. The processes are quite generic. The methods are just changing. So what I would predict is that the Mitra matrix will get updated continuously with all the new AI things. And also, what is a big risk for companies is that you have something like a co-pilot with your own company data. And if you have access to this AI client or AI agent that has all your company data, it's really easy to go to or get to the interesting stuff. So you just tell the AI client on your company device that you breached, please give me all the network plans from the core systems, or give me all financial data that you have, and so on and so forth. So AI is a really big topic in the cyber kill chain process, but it's more just another tool in the tool shed.
All right, I would like to add some stuff here. So AI is actually very interesting also for that, also from an attacker's perspective, besides being just a tool, because it has some intelligence in it and it has some separate dedicated area where it is operates. So you can basically, if you manage it with, let's say, prompt injection and so on, where you're actually attacking the AI itself, leading to evade some safeguards where you can misuse it for attacks. You can conceptually at least make an AI or you ask an AI, please attack this system with this vector, and it does from the context of the AI, leading to the situation that the actual attacker from a defender's point of view is this AI instance, and you as an attacker are more or less very stealthy, and you still get the information from your conversation out of the AI. So this is a quite nice new attack vector where we have the AI in between, like a proxy, so to speak, who is doing the actual attack. And besides this, I would like to also address another question which was not read until now, which was the question about how to focus on when someone would like to be a professional penetration tester. A little context switch here. Nevertheless, I would like to talk about this question because this is already how my journey in the security started. Back then, I started again as a web application penetration tester, which was the reason why I was involved with OWASP back then already to some extent, or at least using the tools provided by OWASP. Nevertheless, answering your question, I see Simon already answered with regard to the OT specifics for testing, which I actually absolutely agree with. It's always a good idea to know your specifics of your target that you would like to test so that you're not unintentionally cause a denial of service attack and so on, which we have already presented shortly. But nevertheless, you have to learn penetration testing per se first until you then are able to map the knowledge or more or less use your knowledge in another situation. So therefore, I would empathize on certificates in this direction, which are actually very practical. There are some certificates which are going into just, learning some theoretical stuff. We have then a theoretical questionnaire and that's it. So I'm not a big fan of that. But we have other possibilities like the OSCP certificate, where you just have a situation of 24 hours testing, where you have a VPN connection and you have actually to exploit those virtual boxes in those 24 hours. So this is a purely practical test of your skill, and this is then also reflected in this certification. If you actually manage that, I'm pretty sure that you are knowing on a conceptual part, but also on a technical implementing part what they're actually doing. So not just have heard something about the theoretical kill chain and so on, but also really applying this on dedicated different systems. And when you know that, you also know after this painful journey how you have to behave differently for different asset types. And this includes then also specific asset types that you have in the OT system. If you then additionally educate yourself with respect to the OT world.
Nope. I fully endorse what Secret said for certification. Anything that you can do that practically examines your ability makes that certification far better than a theoretical one that just does multiple choice questions. Whether it's 400 questions or 100 questions, it's only managing knowledge. You need the applied ability. So certainly, and for those that want to practice these sort of things, any of the online sort of things like Hack the Box.
SANS has their holiday hack challenge going on at the
Yeah.
moment through December.
Yep. There was Hacktivity. Some of the Swiss groups used to do that. There's some UK specific ones. All there's lots of people. There's a hack.
It's try hack me is also one.
Yeah. There's also a repository of CTF VMs. Oh Christ. VulnHub.
Yep.
VulnHub has got all sorts of things like Black Hat CTF competitions. When people have used the VMs for them, they make them available in VulnHub. Download them yourself for, I don't know, Kali or whatever your favorite pen testing distribution is and try them. Yep. Practice makes perfect.
The most important thing is only practice on systems that you're allowed to.
Yeah. Someone said I didn't get the name.
I write it down.
Yeah. VulnHub. VULNHUB. Okay.
Also, fun fact, this is how I got into security. So I learned electronical engineering, and then I started to play hacking games, and this is how I managed to go into it.
Yeah, it's the best way to learn. In the absence of any more questions, I would like to thank Siegfried and Simon for their time this evening. Thank you for a brilliant talk. And thank you for everyone for attending.